Hello, everyone. So my name is Schlezinger, and thank you for joining again for our meetup. I hope you all feel well, and let's start. So the talk is called Typing the Technical Interview. It's based on a blog post by Afir, which is called Typing the Technical Interview, but it's based on Haskell and a very complicated riddle. And I decided to make it work on TypeScript and to use a different riddle, which is kind of simpler to understand. So on myself, I'm Gal Schlezinger. I work at Wix. I build developer tools and performance-oriented tools for Wix, for the Wix front-end teams. We're pretty big. We have lots of front-end engineers. For those who don't know Wix, we have a website builder, and you can manage your business, your entire business with Wix. We have lots of happy customers, and my job and my team's job is to make Wix faster and to help the other front-end developers get tools that they will be able to make their projects faster. I tweet at Galstar, and I blog at hagever.com. And thank you again for showing up. I see we're about 20 people, which is amazing. So let's start. So let's say we're in an interview. This is the scene. We're trying to get a job. And then the interviewer says, in order to test our coding skills, we need to see, they need to see us code, which is a reasonable request. So we say, sure. And then they say, let's do FizzBuzz. And we're like, what's FizzBuzz? And they say, write a program that prints the numbers from 1 to a given number. But for every multiple of 3, print Fizz. For the multiples of 5, print Buzz. And the multiples of both 3 and 5, print FizzBuzz. So if we have n equals 16, the result would be 1, 2, Fizz, 4, Buzz, 5, 7, 8, Fizz, because 9 is a multiple of 3, and then Buzz, 11, Fizz, 13, 14, FizzBuzz, 16. And we obviously say dope. This is the most awesome interview question we got. So what language should we use? And then they say whatever you want. And this is where we as developers can do whatever we want and not just do a boring task in the interview. We can do whatever we want, and we say, we're going to use TypeScript. Well, we're going to use TypeScript's type system, and we won't produce any runtime code. You see, the results will pop up in the editor as if they were code completion. And everything is going to be in a single d.ts file. We're not going to write any TypeScript file, anything that will compile to JavaScript. It's only TypeScript definition file. And obviously, the recruiter is confused. So let's do live coding. I will share the final document in the end if you want to see it. But everything's going to be inside our editor. And I hope you can all see it. Can you see? Can you read it? Is it with nice font size? And if someone is colorblind, should we change to a lighter color scheme? I'm looking at chat. So just waiting for a thumbs up or thumbs down. So we want to implement FizzBuzz, but what's the first thing we need to implement when we have any problem at all? We need to implement a test runner, because test runners, you can't trust on anything from the outside, obviously. So we need to write our own test runner. So our test runner would be as simple as if it compiles in TypeScript, it passes. So the way we're going to do it is we're going to make a type called eq, because it's equals, and it's going to be like that. Equals of A and B extends A equals pass. What that means is that we get an A, we get a type A, and we get a type B, but B has to be contained in the type A. So if we'll write of hello, we can't write world because world has to be one of the types in hello. If we'll have hello or world, this would work. But since we're gonna write everything, and this is what everything is gonna change, we're gonna write everything in type literals. So we're not gonna use string. We're not gonna use number. We're only gonna use concrete numbers or something that wraps a concrete number. So if we say hello, hello must be equal to hello and nothing else, and this is the simplest test runner. And now we need to, because FizzBuzz works on numbers, we need to make our own numbers. What's the problem with numbers in TypeScript? We can say that 0 is 0. But what if I want to say that 1 is 0 plus 1? This doesn't work because plus is something in JavaScript runtime, and TypeScript compiles that to another thing. It just compiles it to 10 plus something, but it doesn't work on types. And so we need to implement our own increment and decrement to do any math operations. And FizzBuzz is all about math, and let's write our math operations that we need to include. So we're gonna need to have increment. Increment is get a number and then number plus 1. I need to have decrement, which is if you get an n, you get n minus 1. And if you get, let's start with this. So how would we implement decrement? I'm going to suggest to look at numbers in a different way, not as 0, 1, 2, 3, 4. We'll have the base number, which is 0. We're not going to use any negative numbers in FizzBuzz because the problem isn't defined in these areas. So we're going to have an increment of number, any number we get. We're going to say that it's n plus 1. So 1 is increment of 0. And if we look what 1 is basically a tuple of 0, comma, plus 1. It's basically a number because this is the represent numbers, and it's fine. It's not better than the other way to represent numbers, but it's not worse. So if we want to have 2, we're going to have the same as increment 1. Whoop. And if we look at it, it's just an increment of 0 and increment plus 1, which is basically 2. And now I'm gonna do a beam magic, which I hope will work. And wait, okay. So I'm gonna do this. Okay. Now let's get this party started. Okay, so now we have the numbers from 1 to 30. Which are all the numbers we're going to use in our calculations and tests. So if you have any questions, let me know. So I'll continue. Okay. So now we have increment, and we're going to need to have a decrement function which decrements a number. To do that, we're going to have a decrement of n. What it's going to be? Basically, we want to say that if increment is, if n is an increment, we're going to want to have this number. Like if this is the number, lower number, we're going to have, we want to have the lower number. Otherwise, we want to have something else. What is the something else? Because we don't want to handle any negative numbers, we're going to define a type called nan, not a number. And it's going to be just the string nan. So how do we take something out of already made type? N can be any type here. So we can say that if n extends increment of some lower number, then take the lower number, otherwise return nan. what is happening here? So n extends increment. It almost looks like JavaScript, but what is this infer function means? It actually means that this could be anything, but give me this concrete type. So if n extends any increment of any lower number, give me the lower number. And the syntax is like ternary. I hope that I say it correctly. I never said it out loud. So it's a ternary. So if we extend it, then we can get a lower number. Otherwise, we return n. Of course, we can't get lower number here because if it doesn't extend increment, we don't have any lower number. So if we test our decrement, we can see that decrement of 1 should be 0. If we'll give something else, it's just not going to work. And it should work on every number. So now we can go up the number scale and go down the number scale up to 30, but we can actually go furthermore because we can do increment of 30 if we want to do it inline, but we're not going to do it. We're going to have to stick with numbers here. So now that we have increment, we need to implement our own subtract function. How does subtract works? Well, basically, in TypeScript type definitions, the only way to do loops is by having recursion. By the way, all of what I'm saying here can be deprecated in the future because there are some issues regarding recursive types in TypeScript, but it's just for fun and to let you know how powerful the type system is. So if we want to implement subtract, eventually we want to have subtract. We want to have a number and an amount. We want to do n minus amount. But again, we don't have this operator, so we need to work with our decrement function, and we need to have some recursion. TypeScript doesn't really allow recursion types. I think they don't allow recursion conditional types because then the compiler explodes or something. But we do have a way to get around their ways. Like we can do all the recursion without their acceptance. The way to do it, or the way to do a maneuver to make it work, is actually to build an object. Let's say A, and let's go. And then we immediately read from the object. So if we'll read hey, subtract will be always ho. But if we'll read let's, subtract will always be go. So we can also do if n extends like 0, then hey, otherwise let's. And then if we'll do subtract of hey, and then we'll do, it doesn't really matter. So my type will be go. Otherwise, if I give anything, it would be go. So this is the way we're gonna take TypeScript. And what we're gonna do is implement subtract in a recursive fashion. How do we do that? We actually get the n, we get the amount, and we're gonna do recursion. So if amount is 0, we're gonna return n. Otherwise, we're gonna return subtract decrement n and decrement amount. And our cases are if amount is 0, then amount is 0. Otherwise, we're gonna return step, which is the recursion step. Let's test it. Subtract. So subtract of 5 and 3 should be 2. So the test pass. If I'll try something else, it won't work. This is a good PDD example. Actually, it's not PDD, but cares. Okay, so we have multiple tests to pass. You can also see that even in bigger numbers it works. So let's go through it again. We have a type subtract n, an amount. Whenever amount is 0, we're going to return n. Otherwise, we're going to do a recursion, and we're going to step into the same type with both decrementing n and amount. So we're going to lower them together until we get to the way that amount is 0. So let me know if you have any questions. If we want to make it as fail-proof as possible, we would also say amount is lower than 0. We would return n or nan or something, but we don't care because we're not going to do that. So we have increment, subtract, decrement. So what's left for us to understand how to do FizzBuzz? We actually need to know we need to know if a number. Sorry about the barking. It's my dog. It's his thing to bark. Oh, does the compiler handle arbitrary depth or does it freeze? It doesn't freeze, but it throws an error. So if the recursion would be too much, I'm not sure what the number is, but it would crash. It won't crash. It's just gonna say that the type is possibly infinite, and it would stop calculating it. And from what I recall, it's just a constant in the TypeScript project. So you can make your own, you can compile your own version of TypeScript, but they don't want to bump these numbers. So it won't freeze, but it will stop evaluating your types. So now that we have both of the three of these, I hope that I answered the question. And I'm gonna continue if I haven't, just let me know and I'll continue trying to explain. So we need to understand if a number is divisible by another number. The fact that we need to know that because we need to know if a number divides by 3, divides by 5, or divides by 15, which is both divides by 3 and 5. So we need to have this divides by the number and divisor. I'm not sure. Let's call it div. So this type will return true if n is divisible by the div. Otherwise, it's going to return false. And how can we make that happen if we only have increment, decrement, and subtract? So the way to do that is a simple formula. Let's say we have n of 10 and we have div of 3. That 3 doesn't divide 10. What we're going to do is 10 minus 3, and then we have 7. Minus 3 again is 4. Minus 3 again is 1. Minus 3 is negative 2. So if we have a number, again, we're gonna subtract the divisor. I'm not sure how you say it. So we're gonna we're gonna just subtract the divisor from the number until we get to 0 or lower than 0. If we get 0, like we have 9, which is 3 minus 3 or 0. So 9 minus 3, and again minus 3 and minus 3 is actually 0. So if it's 0, the number is divisible by the other number. Otherwise, if it's lower than 0, it's false. So we're going to say if it's lower than 0, we're going to return false. If it's 0, we're going to return true. Otherwise, we're going to do the recursion we talked about earlier. So it's going to divide by subtract and div. So now we're going to let's say we have the 10 and 3. So if we have 10 and 3, this would be 7. And then we're going to check if 7 is divisible by 3. And this is the same logic that we did here. And our guards and our conditionals are going to be that if n extends none, then it's lower than 0. Otherwise, n extends 0, it's going to be 0. Otherwise, it's a recursion step. Okay, so gonna write the tests. If you have any questions, let me know in the chat. In the meantime, let's divide by. Okay, so we have divides by, let's say 30 and 15 should be true. Okay, can't be false. Cool. 30 and 10 should be true as well. And let's say 15 and 4. So we have divide by that works. I don't see any questions, so I just gonna continue. If you have any questions, again, just let me know. I'm seeing the chat here all the time. So what is divide by 3? It's actually the simplest type we have here. Divides by 3 is takes an n and divides by n3. Both sides going to be the same. Now we can actually do 15. Yeah, Bartosz, I think it's Bartosz. Sorry if I pronounce it wrong. We will share the code later. I also wrote a blog post about it, and I'll share it as well, which has all the explanations. So divide by 15 can be as simple as divides by 15, but it's not interesting. What we would actually want to do is divides by 3 and divides by 5. But this doesn't work. Why doesn't it work? This thing isn't implemented for types. So let's implement a type that works the same. By the way, okay. I have a lag as well. So so we're gonna have end. We're gonna get two variables, 2 arguments. Yeah, you're gonna get the video of the event. It's gonna be fine. Don't worry. Okay, so and let's say we're gonna want to implement this. Divide by 3 and divide by 5, and we're gonna get 2 booleans. So we're gonna say if A extends true and B extends true, then true. Otherwise, false. This is very ugly, but it will also work on JavaScript. So the syntax would work, and we can now extract our operator to just use our and. Okay, cool. So now divides by 15 is literally divides by 3 and divides by 5, which is, again, a nice way to know it. The fact that I even do it and not just do divides by _15 is because I think it's cool to learn this, and this is very, very usable in production apps as well. To know if something is true and this is true, this is very good and very cool. So now we want to have FizzBuzz for a single number. Let's say we're going to get just 3. We need to get back Fizz. So if we get n, we should get or the n, or we're going to get Fizz, or Buzz, or FizzBuzz. This is not how we're going to write it because we need to have some logic. And this way of nested ternaries, I don't like that. So let's build our own if statement. We're going to have options, which are going to be in a specific form. When we say that something is in a specific form, we can actually get stuff in the type system, while in this type system. So let's look at an example and then it will be clearer. So we're going to say that options is going to be an object, a conditional, which is going to be a Boolean, and Boolean, which is true or false. We're going to have a then clause, which can be any, and we're going to have an else clause, which is going to be any. What this gives us is the ability to have options and then take something out of the options. It's basically like saying something like conditional extends Boolean, any. It's like having a named argument. Like in JavaScript, we have destructuring. This is almost the same. So we can say options conditional extends true. We're going to say we're going to return options then. Otherwise, we're going to return the else. Okay. Let's look at it in a single line. And let me know if something here is very weird. Let me know in the chat. I'm going to continue. So in order to use this if statement, it's just an if, and we're going to pass a conditional. So the first conditional would be if n divides by 15. If n divides by 15, we're going to say FizzBuzz. Otherwise, we're going to have a nested if. Condition is divides by 3. If n divides by 3, we're going to say Fizz. And then again, condition if divides by 5, then buzz. Else, we're going to return the n, just the n itself. So we have FizzBuzz, Fizz, buzz. The fact that divides by 15 is before the 3 and 5 because divides by 15 divides both by 3 and 5. It needs to be before, so we would short circuit the if. And let's test it. So if we'll have test FizzBuzzNth, okay. PQ FizzBuzzNth of, let's say 1. It should be 1. Right? Cool. 2 should be 2. 3. What should 3 be? Oh, it auto-completes me. This is the best testing framework there is, ladies and gentlemen. Buzz, now we can see that if we go to 15, we're going to have FizzBuzz. If we get to, say, plus 20, 20 should be Buzz. Let's go to something that doesn't. Okay, so this should be 19, and we also have 30, which is going to be FizzBuzz. So we have a working FizzBuzzNth, which is the nth element in the FizzBuzz, which is very cool. I think that even with this type, the recruiter would be happy because it's kind of amazing what we achieved with only the type system. But let's take it a bit further. What we want to have also is FizzBuzz that takes a number and returns an array of results. So TypeScript type system doesn't have any way of using arrays or concat stuff, but we do have in the type system a nice thing called a tuple. A tuple can be just an empty array, or it could be a string and a number. You can also make a type which is a tuple of literals. And the nice thing about it is we can actually hack the compiler to have the unshift function. Unshift is a function that gets an element and pushes a new element into the tuple or the array, but it pushes it from the beginning of the array. So if we have a new element of, let's say, hi, it will be here. It will be at the end, like push in JavaScript. So let's implement unshift. And it's going to be very, very weird. So let's say I have an element and I have an axis. We're going to use the fact that axis is some kind of array or some kind of tuple. So we need to see that in front. The type would only work for these kinds of arguments. So what we're going to do is to say that I want to get, I'm going to construct a function. The function would be with this signature. We're going to have the first element is going to be the element we got, and the other elements are going to be the list of elements we got here. So this is actually a function, and TypeScript has a parameters utility type that lets us to get only this part. And this is the way we do nasty things just to make ourselves happy and make TypeScript probably miserable. So now if we'll look at unshift, and we'll see that unshift of 1 to an empty array would result in 1. Otherwise it would fail. See that it actually works. Okay, so now we have unshift. This is an important thing to understand before we dive into the last type, but not the last half we're gonna do. So the last thing we're gonna implement is FizzBuzz for all the numbers, and we're gonna use an accumulator, which is gonna be the result. The result is gonna be just like the unshift is gonna be a tuple. So the result is gonna be a tuple, and we're gonna give it a default argument because we don't want to provide the result every time. We don't want to provide the result on the first run. We're going to construct it by ourselves. So what we're going to do is basically say that if we finish, we're going to return result. This is a way, a technical optimized way to do stuff, and this is how it's going to work. So our recursion step, everything is going to be in our recursion step. And when finished, we're just going to exit and return the result. This is our loop. What is your level on Code Wars or Lead Code? I don't know what it is. So probably 0. But thanks, Sasha. Okay, so FizzBuzz. We're going to say the first thing we're going to do is to construct an array of all the results. Construct an array of all the numbers from 1 to the provided n, this one, to the provided number. The way to do it is to call FizzBuzz when we decrement the n one time, and the result, let's keep the result this way right now. So we'll focus on the conditional. So what is the conditional? What makes us finish? So we're going to finish when n extends 0. Otherwise, we're going to stack. And if we look what our result for this is, it's just an empty array because we haven't altered result type here. But what we can do actually is to unshift n. This would prepend the number n to the result every time. And now we'll get, you can see here, we're going to get 1, 2, 3, etc. This is not enough because we actually want to unshift FizzBuzzNth. And if we'll go here, we're going to see that we have 1, 2, and then Fizz, which is already, I imagine, some claps. It's kind of weird because we're all remote. But this is already amazing, and if the recruiter is not passed out, so he would be very, very happy. But it's not enough, for me at least, because these aren't numbers. He asks specifically for specific numbers and not our representation. So how can we make all this code work with numbers? You can see that we already have all the tests. So I'm going to suggest something that is very hacky. Yeah, thanks for the claps. I'm going to suggest something that is very hacky and it's very limited, but it's going to get us the ability to make all the tests, almost all the tests pass, and still work with real numbers, with digits, not with our representation. How we're going to do that? Great, thanks, Bezu. I agree that it's crazy. So we're going to have an increment. Let's change the increment. The only thing that makes our representation different from digits is increment and decrement. All the other things should work. Let's change the increment. What we're going to do is basically have a list of numbers, and then we're going to extract n out of the number. I'm going to paste here a different. I'm going to paste here a list of numbers, but I want just so you understand. So let's say I'll get n, which is 0. So I'll get the first element, which is 1. If I provide 1, I'm going to get 2. If I provide 2, I get 3, 4, etc. So what we're going to do, I have FizzBuzzNth. The last times I implemented it, I have implemented it. I was wrong on the space, so I don't want to be wrong here. So I'm just gonna paste everything. But this is weird. This extract and number. This is basically like casting. We're about to say to the compiler, believe me, this n is a number. I'm not sure. I think that if you provide something that is not a number, it's gonna crash on your end. Let's see. Increment. It's just gonna be lots of numbers. So it basically says, if it's a number, give me that number. Otherwise, give me just number. Give me just the type number, all the group of numbers, which is cool. So now we have an increment, which actually works, because if we'll take a look, 6 is 6, 7 is 7, all the numbering actually works, also 30. But decrement doesn't work. In order to make it work, we're gonna copy increment. We're gonna do something that isn't that nice. Decrement. Gonna have nan and then 0. So if I provide 0, I'm gonna get nan, because not a number, because I'm gonna get a negative number. If I provide 1, I'm gonna get 0, and that's it. This is our entire math. And this is what's crazy here, because if I'm gonna provide 4, then decrement 1 will say that it's 0 actually, and it doesn't work. Also, subtract would be the same. All the tests still work because we only change the representation of numbers. All the math above it is the same. But it means that FizzBuzz, our last type, if I'm gonna ask my editor to understand what's going on here, it's probably gonna output what we want, which is 1, 2, Fizz, 4, Buzz, Fizz, 7, 8, Fizz, Buzz, 11, Fizz, 13, 14, FizzBuzz, and 16, which is exactly what the recruiter asked. And I think we're gonna get the job. What do you think? And basically that's it. I'm gonna share the code, and thank you for being with me and listening to this weird stuff. And thanks again.